maps are powerful tools. They help us navigate, understand our place in the world, and learn about different cultures and geographies. But maps can also be deceptive. This is because all maps are projections. To create a map, cartographers project the Earth's curved surface onto a flat plane. This process inevitably introduces distortions in size, shape, distance, and direction. Some distortions are minor and easily overlooked. Others are more significant and can lead to misunderstandings about the world. By understanding how maps distort reality, we can become more critical map readers and avoid common misconceptions. The Mercator projection, created by Gerardus Mercator in 1569, is one of the most widely recognized and used maps in the world. It is a cylindrical map projection that distorts the size of land masses near the poles while preserving angles and shapes. While useful for navigation, the Mercator projection grossly distorts the relative size of continents. Greenland, for example, appears larger than Africa, but in reality, Africa is 14 times larger. Europe also appears much larger than it is relative to South America and Africa. This distortion has real-world consequences. It reinforces Eurocentric biases and creates a misleading impression of the global distribution of land and resources. The fundamental problem with mapmaking is that it attempts to represent a three-dimensional object, the Earth, on a two-dimensional surface, a map. This challenge has perplexed cartographers for centuries, as they strive to balance accuracy and usability. This is inherently impossible to do without introducing some degree of distortion. No matter how skilled the mapmaker, some aspects of the Earth's surface will always be misrepresented. Think of trying to flatten an orange peel. The peel, like the Earth's surface, is curved and three-dimensional. You can smooth it out, but you'll inevitably create rips, tears, or stretches. These imperfections are akin to the distortions seen in maps. The same principle applies to mapping the Earth. When cartographers attempt to flatten its curved surface, they must make compromises. Any attempt to flatten its curved surface will require compromises. These compromises result in various types of map projections, each with its own strengths and weaknesses. Different map projections prioritize different aspects of accuracy. Some focus on preserving shapes, while others aim to maintain accurate area representation. Some, like the Mercator, preserve angles and shapes, making them useful for navigation. This projection is particularly valuable for sailors and pilots who need to chart a straight course. Others, like the Gall-Peters projection, prioritize accurate representation of area, even if it means distorting shapes. This projection is often used in educational settings to provide a more equitable view of the world. Each map projection serves a different purpose, and understanding these differences is crucial for interpreting the information they present. Whether for navigation, education, or general reference, the choice of map projection can significantly impact our perception of the world. The history of mapmaking is long and fascinating. It spans millennia and reflects the evolution of human understanding and technology. From the earliest days, humans have felt the need to chart their surroundings, to make sense of the world they inhabit. Humans have been creating maps for thousands of years using a variety of materials and techniques. Early mapmakers used whatever resources were available to them, from animal hides and parchment to stone and clay. Each map was a unique representation of the world as understood by its creator. Early maps were often crude and inaccurate, relying on observation and estimation. These maps were more than just tools for navigation. They were also expressions of the culture and knowledge of the time. They often included mythical lands and creatures, reflecting the beliefs and imaginations of their creators. The Babylonians, for example, created clay tablets depicting the world as a flat disk surrounded by water. These early maps were not just practical tools but also held religious and symbolic significance. They represented the Babylonians' view of the cosmos and their place within it. The invention of the compass and the development of trigonometry in ancient Greece led to significant advances in mapmaking. These innovations allowed for more precise measurements and more accurate representations of the world. Greek scholars began to understand the world in new ways, leading to maps that were more detailed and reliable. Greek scholars like Ptolemy produced remarkably accurate maps of the known world. Ptolemy's work laid the foundation for modern cartography, introducing concepts such as latitude and longitude that are still in use today. His maps were used by explorers for centuries, guiding them to new lands and discoveries. The age of exploration brought about a renewed interest in cartography. As European explorers set out to discover new lands, the demand for accurate maps grew. Cartographers worked tirelessly to update their maps with the latest discoveries, leading to a more comprehensive understanding of the world. European explorers relied heavily on maps to navigate uncharted waters and discover new lands. These maps were essential for planning voyages and ensuring safe passage. The work of these explorers and cartographers expanded the known world and brought distant lands closer together. Today, with the advent of satellites and GPS, we have access to incredibly detailed and accurate maps. Modern technology allows us to see the world in ways that were unimaginable to ancient map makers. We can explore every corner of the globe from the comfort of our homes thanks to digital maps and satellite imagery. However, even these modern maps are not without their limitations. Despite the incredible accuracy of satellite imagery, there are still areas of the world that are difficult to map. Factors such as weather, terrain, and political boundaries can all affect the accuracy of modern maps. As our technology continues to evolve, so too will our maps, bringing us ever closer to a complete understanding of our world. Section 5. Eurocentrism and Cartographic Power. Whose worldview is represented? Throughout history, maps have often reflected the worldview and biases of their creators. These biases are not just incidental. They are deeply embedded in the way maps are designed and used. The creators of maps, often influenced by their own cultural and political contexts, have the power to shape how we see the world. During the Age of Exploration, European powers used maps to assert their dominance over colonized territories. These maps were tools of empire, depicting newly discovered lands in ways that emphasized European control and influence. They were not just navigational aids but instruments of power and propaganda. The Mercator projection, with its Eurocentric distortions, exemplifies this phenomenon. Created by Gerardus Mercator in 1569, this map projection was designed for navigation, but it significantly distorts the size of landmasses, making Europe and North America appear much larger than they actually are. By exaggerating the size of Europe and North America, the Mercator map subtly reinforces the idea of European superiority. This distortion has had lasting impacts, influencing how generations of people perceive the relative importance of different regions of the world. Even today, many maps continue to reflect Eurocentric biases. Despite advances in cartographic techniques and a better understanding of the world, the legacy of these historical biases persists. Modern maps often still place Europe at the center, perpetuating a worldview that prioritizes European perspectives. For example, the standard convention of placing north at the top of the map is arbitrary and reflects a Eurocentric perspective. This convention dates back to the Renaissance period in Europe, when mapmakers began to standardize the orientation of maps with north at the top. It's important to remember that maps are not objective representations of reality. They are constructed by people with specific viewpoints and agendas. The choices made in mapmaking, what to include, what to omit, how to represent different areas, are all influenced by the mapmaker's perspective. They are products of human perception and interpretation, shaped by cultural and historical contexts. Understanding this can help us critically evaluate the maps we use and recognize the power dynamics they reflect. By questioning the biases in maps, we can strive for a more inclusive and accurate representation of our world. Section 6. Beyond the Mercator, exploring alternative projections. Fortunately, the Mercator projection is not the only way to map the world. Many alternative projections offer more accurate representations of the Earth's surface. The Gall-Peters projection, created by Arno Peters in 1974, is one such alternative. It accurately represents the relative size of continents, although it distorts their shapes. Other projections, such as the Robinson projection and the Winkel-Triple projection, offer compromises between area accuracy and shape distortion. Section 7. The Peters projection, a more accurate view but not without its critics. The Peters projection, while praised for its accuracy in representing area, has also faced criticism for its distortions in shape. Some argue that it makes high-latitude regions appear stretched horizontally, while equatorial regions appear compressed vertically. Despite these criticisms, the Peters projection remains a valuable tool for challenging Eurocentric biases and promoting a more accurate understanding of global geography. Section 8. The importance of map literacy, reading between the lines. In a world saturated with maps, it's more important than ever to be map literate. This means understanding the limitations of maps and being able to critically evaluate the information they present. When you encounter a map, ask yourself, what projection is being used? What are the potential distortions? What information is being emphasized or omitted? Who created the map and for what purpose? By asking these questions, we can become more informed map readers and avoid being misled by cartographic distortions. Section 9. Conclusion. Maps as tools, not truth-tellers. Maps are powerful tools for understanding the world, but they are not perfect. All maps distort reality to some extent. By understanding the limitations of maps and the biases they may reflect, we can use them more effectively and responsibly. The next time you see a map, remember that it's not just a piece of paper. It's a representation of the world, shaped by human perspectives and choices. By reading between the lines and questioning what we see, we can develop a more critical and nuanced understanding of our planet and its people.